All right, so you should have a table like this for both sine and cosine that was included with this task for this week. So if you want to print that out, or if you can print that out, that's helpful. It will be part of what's due this week is this table. So I'm not going to have you fill out the approximate, that's the decimal. So go ahead and pause, and I want you to fill out both the sine and the cosine version of the table, and then that'll be part of your work, as I only have a couple problems for this section. All right, so hopefully you had time to do that. You paused your video. I'm just going to go quickly through this. So remember sine, those are my y values, and if I just go around the unit circle at 0 degrees, I'm at 0. Pi over 6, it's a positive 1/2. Pi over 4, root 2 over 2. And then we go root 3 over 2, and at pi over 2, I'm at 1. And then I go back down again. And 1/2, and then I'm at 0. So notice if you look at these values all get bigger until they hit 1, and they all get smaller until they hit 0, between 0 and pi. That's going to kind of give us a clue to what the shape looks like. All right, and then if I come down here for the negative half of the unit circle, still at pi, that's 0. And if I go at negative 7 pi over 6, that's negative 1/2. Negative root 2 over 2, negative root 3 over 2, and then I'm at negative 1, so that's my minimum. And then I go back up again, negative root 3 over 2, negative root 2 over 2, negative 1/2, and at 2 pi, I'm back at 0. All right, so those are sine. I just really went around my unit circle, and I just put all these y values in. We used to have you do the approximate, because then we had you graph all of these. And really there's an easier way to graph it. So I really just care that we're looking at what we can tell about sine and cosine from the numbers before we put them on a graph. All right, so cosine, these are all my x values. So at 0 radians, I'm at 1. So I start at my max on this one. Remember, you started at 0 with sine. And then I go root 3 over 2, and then root 2 over 2, and then 1/2, and then 0. So start at my max, I go down to 0. At 2 pi over 3, I'm at negative 1/2, negative root 2 over 2, negative root 3 over 2, and then negative 1, and that's my minimum. All of that between 0 and pi. I'm kind of pointing that out because that might show up in the problems associated with this task. All right, so then at 7 pi over 6, I'm at negative root 3 over 2, negative root 2 over 2, negative 1/2. Down here at 0, at 3 pi over 2, and then I start making my way positive again at 1/2, root 2 over 2, and a positive root 3 over 2, and back here to 1. All right, so again, make sure you keep these. These are going to be helpful in making our graphs, which is part of this first lesson. All right, so we've got those done. All right, so graphing sine of t. So originally, how I kind of taught this was I had you take all those approximate numbers and put them in, but we're going to use the big numbers. So we noticed that we're going to use all these main points. So notice how a whole cycle or a whole period of sine I can do between 0 and 2 pi, and I can divide it into 4 parts. So that's kind of the key to graphing it. But sine graphs always start at 0. And if you looked at your 2 pi from your tables, I'm just looking at this, I also end at 0. But so I just want to look at the main important points. So what happens at pi over 2? What happens at this first quarter of your graph? Well, you're up at your max of 1. And then if you come back down to pi, you go back down to 0. So 0 to pi, you've hit your max and come back down to your, like, kind of your average point. And then you go down to 3 pi over 2. I'm here at -1, and then back up to 0 at 2 pi. And then you just kind of want to fill it in a nice curve. So my curve will probably not be as nice as yours. Oh, it's not turning out too bad. And come back up. All right, so there is your sine curve. And when we look at graphs, if you remember the first part of our year, we spent a lot of time describing them. So make sure you pause and take notes, and especially include 0 to 2 pi, the 1 and -1, and then pi over 2, pi and 3 pi over 2 in your notes, because that's going to help you with the next slide. All right, so we're referring to our sketch graph. What is the domain? So the sine graph doesn't just stop. It doesn't just start at 0 and end at 2 pi. It goes on forever. So we have a domain of all real numbers. And then we want to talk about intervals of increasing or decreasing. And so notice I'm increasing between 0 and pi over 2. So I don't know if you remember doing interval notation for this, but this is when f of x, or f of t in this case, was increasing. I decrease between pi over 2 and 3 pi over 2. Oops, I should leave room for my increasing because I have another section. So this is going to be pi over 2 to 3 pi over 2. And then notice that at 3 pi over 2, I start increasing again. So we're going to say that we also have increasing from 3 pi over 2 to 2 pi. We're just going to put it in like that. What is the range? So the range is the max and min values in the y, and we go from a -1 up to a +1. So my range is going to be -1 to +1. And that makes it pretty easy to fill out my min and max value. So my min is -1. My max is 1. We have some zeros, but I'm not really going to focus on the symmetry of the zeros right now, but we want to talk about a period. So remember, the definition of period is when you can complete one cycle, and we complete one cycle 0 to 2 pi. So that is describing our sine graph. This is really important for your notes for your assignment that's associated with this. All right, now we got cosine graph. So you're going to want that other table. And the cosine graph, it starts at 1. So over here at 0 radians, we are at 1. And then at pi over 2, we are at 0. And then at pi, we are down here at -1. So we're down at our minimum. And then we come up to 3 pi over 2, we're at 0 again. And then at 2 pi, we're at 1. So we start up here, and then we want to draw like a nice smooth curve. And it should look like that. And now I just want to see if I can fit both of these graphs on the same page. So this is your cosine. Let me zoom out. Cosine is up on top, and here's your sine. And what I want you guys to notice is that I start at my max here, and I start at my min here. But look, it becomes a cosine curve here. So the difference between the cosine curve, because I start at my max, and the sine curve, when I hit my max is 90 degrees. That's the difference between cosine and sine, is this 90-degree shift. So something just to note there, it's really important for you guys going on to calculus, and those of you who stick with me to the end, we do some identities the last week for those who are going on to calculus. All right, the other thing I want you to notice about these two graphs is how we graph them. So cosine, we start at our max, we go to our 0, we go to our min, and then we go 0, and then we go max. That is the cosine pattern. So all graphs kind of have patterns, and this is the cosine pattern. Sine pattern, however, is we start at our 0, we go max, we go 0, we go min, and back to 0. That's one period for that. All right. So keeping your cosine graph out, we're just going to finish up this video by describing my cosine graph. Domain is the same. I mean, this graph describes sound waves and light waves and waves of the ocean, and so the domain is really all real numbers. It never stops. Cosine is a little bit more straightforward for its periods of decreasing. So if it starts at max and goes to its min between 0 and pi. So we got 0 to pi, and then where we see it increasing kind of starts at pi and goes up to 2 pi. And then it starts all over again. The ranges are the same, -1 to 1. The minimum is the same. The maximum is the same. We described our zeros on the actual graphs, and so that's kind of where the zeros come in. Symmetry on cosine is actually even symmetry. You can reflect it over itself. It's a mirror image, where sine is actually odd symmetry, but we're not focusing on that remotely. And then the period in the same thing is just going to be this 2 pi. So 0 to 2 pi, that's one period when I have my parent function, which is just cosine of t. All right.